when we started aerOS because there was a need, okay, because there was a large data explosion, and there were evolving capabilities of needs and support of virtual infrastructures in different environments. So this creates the need of developing a new paradigm for data and computer resource management, okay, supported by different or by a meta operating system concept and with orchestration, all across the cloud edge IoT continuum, starting on the sensors and the smart devices, following macro edge, far edge, and finally to the cloud. So it's true that for the last years, it has been needed to improve or to perform the processing closer to the sources of the data in order to save bandwidth, reduce latency, improve security, and different aspects. And aerOS is also focused on solving that issue. Okay, so things that we should solve regarding aerOS, we have a wide variety of deployment model and open standards. There is not a single standard. Okay. Additionally, we have existing legacy investments, and we have seen that in all the use cases in which we have been involved in the, I will say aerOS, but in the last 10, 12 projects in which we have been involved with edge computing. Additionally, we also have the needs of integrating all the different technologies in an homogeneous continuum in order to deploy things where we need to deploy. So we have cloud centricity, we have network management, virtualization, and security and trust as main issues to be solved. Okay, so aerOS, we define it academically, you know, an overarching goal when we launched the proposal, and is to design and build a virtualized platform agnostic meta operating system for the IoT Edge Cloud Continuum, and to execute this meta operating system in the component that we have defined as infrastructure element that we later on we will see it in the architecture, and completely independent from the underlying hardware and operating system. Actually, the issue of portability that has been dealt for years and years, but focused on virtualized environment. So aerOS for us will deliver virtualized services, so it will enable orchestration and will be efficiently supporting frugal and explainable AI in the different use cases, completely agnostic, will provide an API available anywhere, every time, and it will be flexible and platform agnostic. Additionally, it will include a set of infrastructural services in different components of the continuum. And for that, we will distribute software tasks in the different components. We will support intelligence, so we will be able to make decisions close to where events are being created or being detected. We will support the execution of services using abstract resources. We will see that in the architecture. So for us, virtual machines, container, abstract components are key in aerOS architecture. And the most important thing is orchestration. We'll orchestrate abstract resources that will be deployed in different elements in order to be able to execute what we call a service chain. And additionally, data autonomy and scalable data autonomy, because at the end of the day, everything is related with data, okay, it will be managed by aerOS. So, most important thing, we focus on a generic approach. aerOS is completely generic and can be applicable to any vertical with just a slight modification. So we have 5 different pilots in aerOS, one of the pilots with different corollaries, as we will see later on. But the idea is that aerOS can be applicable to any vertical. So the idea is to orchestrate the continuum, and orchestrating the continuum is not, let's say, a one-dimension process. You know, it's resource, services, data, and network orchestration. We have different techniques in order to be able to implement the meta operating system, virtualization, data management, artificial intelligence and analytics, and security and trust. And these relevant techniques, including also the orchestration, are key in the different work packages and the different tasks that we have within the work plan. We want to see it in that way. Okay, so Sorry. The 5 pilots that we are and use cases that we are discussing will be supporting the aerOS architecture, high-level architecture that in the next presentation, technical coordinator will be presenting to you. And the 5 pilots are the first one related with manufacturing. This is the one that we have split in 3 different sub-pilots. We have renewable energy, in which we have created a real container which contains edge computing with virtualization inside. Machinery for managing different components in a farm, but it can be also applied to road construction, led by TT Tech and John Deere, and also maritime ports. We always, in all of our projects, if you have been involved with us, we love to include a pilot related with ports, okay? And another one related with smart buildings in order for having energy efficiency and energy management. So what we have observed is in aerOS, we are relying on open source component. We customize different developments and integration, and everything that we are developing will be open source. We are trying to create, or we are working in impact-oriented use cases, but all the time, although we are using open source components, we are respecting their legacy infrastructure. For example, I can put you the example of the maritime ports. You know, in the Eurogate container terminal that we are working with in Limassol, we cannot avoid using the legacy infrastructure that is available, for example, for the big cranes. You know, they are worth millions. So trying to avoid to use them is a nonsense. And the idea is that it has impact and it's exploitable. Additionally, we want to aerOS to be as lightweight as possible. The advantage of being lightweight is that we will be able to execute aerOS in smaller components and smaller devices, so we will be able to bring aerOS closer to the different events. Decentralization, we have different architectures, distributed, centralized, decentralized. aerOS is decentralized in every outcome, in everything that we are developing. So we want that aerOS is as much compatible as possible with container management frameworks, different processing architectures, and different data formats. Okay, so aerOS, here we have 3 figures that are key for everything that we are discussing all the time. We are following an agile methodology with analysis, design, implementation, testing, feedback, and the different analysis of the requirements. And additionally, we have the structure of the work packages that reflects the different activities that we are doing. This work plan that we are using in aerOS is structured in 6 work packages. One work package is coordination and management, and work package 6 is impact creation, including anything related with exploitation and business. Work package 2 is related with the architecture. That is a project that was finished in month 21. And right now we are involved in work package 3 and work package 4, that is developing the main components. And additionally, work package 5, that is the integration and the different use cases and validation. On the right side of the slide is the evaluation methodology that we are using. We start with the requirements. With this, we have defined the concept. With this, we define the deployment. And with this, we go with the use cases exploitation. We evaluate the stakeholder requirements, the concept, the prototype, and how it is applied in the different use cases and business scenarios. So with this, we create impact, and later on, we have the ecosystem building that in our case is represented by the 27 partners and the different partners that are coming, the third parties that are coming from the open goals. Okay. Additionally, this is important for you to know. For example, Tania is involved in this cluster. Okay, aerOS is part of the EU Cloud Edge IoT.eu cluster of projects. Okay, we can see that from the 6 projects that were approved in this call, we are in aerOS that is related with operational edge, and there are other 5 projects, ICOS, Fluidos, Nebulos, Nemo, and Nefele, that are located in different parts of the supply side, demand side, and different levels of the computing continuum. So this is the portfolio that is being created by the different projects. Additionally, In the cluster of projects, there are other projects. For example, is Assist IoT that was also coordinated by UPB, by us, and was involved in this consortium. And now in the new cluster, new projects are coming, like for example, Enact, in which we are also involved and will provide different aspects related with the continuum. So this is the idea of presenting aerOS in a nutshell, just for you to be located and see where we are moving, what we are doing. And now we will continue with the presentation focused mainly on the architecture and the different technical developments. So Nacho, I give back the